In this video, we will discuss about amyotrophic lateral sclerosis pathogenesis mechanism. So before going into the mechanism, let us first discuss slightly about this disease, that is amyotrophic lateral sclerosis or ALS. In this disease, what happens is that the motor neuron gets damaged, and because of the damage of this motor neuron, the voluntary muscles get paralyzed, and this will cause problems on the patients. So main reason for this kind of disease is amyotrophic lateral sclerosis is genetic mutation. In some of the cases, the genetic mutations are inherent. However, in most of the other cases, the genetic mutation is not inherent. They are basically the result of environmental factors, their lifestyles. And so, what is the main cause of this amyotrophic lateral sclerosis? It is that this mutant SODI. It is the main cause that has been found in uh, this ALS affected patients. So this SODI does is that it will create situation that will cause ER stress and uh, affect the efficiency of proteasomal degradation and also cause mitochondrial stress. And combined effect of this will leads to caspase activation, and that will finally lead to cell deaths. And this SOD mutant SODI will not only secreted by this motor neuron, however it is also secreted by other components such as astrocytes and macroglia. And in our previous video, we have understand the function of this astrocyte and macroglia is that these astrocyte and macroglia are remain in uh, equilibrium to maintain this glutamate. However, in this case also, this glutamate is not been able to properly maintained between glutamate content is not been able to properly maintained by astrocyte and microglia, as this EAAT2 receptors that is used to take up the microglia are become inactive. Because of this, it will cause excitotoxicity, and that along with the mutant SODI will cause the disease progression. And some of the literatures also says that the mutant SODI itself is not enough for the progress of this disease. So the other factors such as this glutamate that cause toxicity will along with this mutant SODI will promote this kind of disease progression. And because of the this SODI mutant, what will happen is this microglia and astrocyte will also release toxic factors such as NO, TNF alpha that will affect the motor health of the motor neuron and progresses them towards cell death or progressing them towards that. And these microtubule filaments, uh, because of the unfolded protein structure, will cause an impact on the motor functioning, and all this will finally leads to paralysis of voluntary muscle that will cause uh, amyotrophic lateral sclerosis. And And this kind of unfolded proteins is can be evident or can be rationalized from the ER stress, as we know that ER stress, one of the reason for ER stress is unfolded protein response. And this unfolded protein response, when create ER stress, the quality control of this ER stress will get compromised, and because of this, unfolded proteins might leak from the endoplasmic reticulum, and aggregation of these unfolded proteins uh, might sometime forms this microtubule, or it will alter axonal transport. And this, and one more thing that might cause the RNA, that might affect the RNA processing, is that the mutant TDP43 and mutant FUS, and both will affect the RNA processing and will initiate epigenetic changes. However, the actual reason how this mutant TDP43 and mutant FUS works in this disease condition is not yet properly been identified. So, I hope you have understood something about this amyotrophic lateral sclerosis pathogenesis mechanism. And if you need to understand this thing in details, you can go through the reference that has been provided in the description. So that's all for this video. Thank you for your time.